Section 1.3, Definition 1, Trigonometric Functions. In this section, we have two objectives. Objective A is what we'll be looking at first. Find the 6 trigonometric functions for a given angle. So definition 1, what this whole section is built off of, states if theta is an angle in standard position and the point xy is any point on the terminal side of theta other than the origin, then the 6 trigonometric functions of angle theta are defined as follows. Sine of theta, which equals y over r, cosine of theta, x over r, tangent of theta, y over x, cotangent of theta, x over y, secant of theta, r over x, and cosecant of theta, r over y. So if we look at figure 1 here, we see that we have a angle theta, all right, and that's given by, let me use a different color, angle theta right here. And this angle theta is on our coordinate plane xy. We then have a point xy, and this point is on the terminal side of our angle theta. All right, and so this is our point xy. Okay, so this has a distance of x and a distance of y, as noted on the legs of the triangle that's formed with our terminal side. Okay, so the 6 functions that we just went through, sine, cosine, tangent, cotangent, secant, and cosecant, happen to represent the 6 possible ratios that can be made from the numbers of x, y, and r, which are the 3 sides of our triangle. So everything is related to each other. Okay, and r is the distance from the origin, all right, which is the center here, 0, 0, to our point xy. Okay, so let's look at an example exercise problem. So find the 6 trigonometric functions of theta if theta is in standard position and the point 1, -4 is on the terminal side. So let's draw our coordinate plane to start off with. We have the y-axis and the x-axis. Okay. Now we know we have a point on the terminal side of theta at 1, -4. So 1, -4 would be about here. So we have our terminal side that goes through this point, 1, -4. Okay. So knowing this, we can then identify our angle theta. Okay. So our initial side always starts on the x-axis and it goes in one complete rotation, and then it lands on our terminal side that has a point 1, -4. Okay, so r, right? R is the distance from the origin to our point. Okay, so r would be this distance right here, and let me give a different color. So this right here would be r. Okay, now we need to find that distance. We know what x and y are because x and y are given by our point. And so we can use x and y to find r. And r is given by the formula x squared plus y squared, all under the square root. All right. And so we can substitute in our values. So we know x is 1. And we know y is -4. So if we were to simplify, we'd have 1 plus 16, which simplifies to the square root of 17. Okay? So we have r equals the square root of 17, x is 1, and y is -4. Since we know every side of our triangle, we can then use these values to write the ratios for each of our 6 trigonometric functions. Okay, so sine of theta is y over r, which would equal -4 over the square root of 17. Cosine of theta equals x over r, which is 1 over the square root of 17. Tangent of theta is y over x, which equals -4 over 1, which simplifies to -4. Okay. Cotangent of theta is x over y, which is 1 over -4. Secant of theta is r over x, which equals the square root of 17 over 1, which simplifies to the square root of 17. And cosecant theta equals r over y, which is the square root of 17 over -4. And these are the 6 trigonometric functions for theta. All right. Our next exercise asks us to find the sine and cosine of 60 degrees. Okay. So first we need to find a point on the terminal side of an angle with a measure of 60 degrees when we draw it in standard position. So let's start off with our coordinate plane. We'll just use the first quadrant here. All right, we have a 60-degree angle for theta. Okay, and we need a point on the terminal side. And then we'll just draw our dotted line here to form our reference triangle that we're using to answer this problem. And a reference triangle is just a triangle that's formed by drawing these dashed lines from the point on the terminal side just to the x-axis. Okay. And so when we do this reference angle, we know we formed a 90-degree angle. And so we've then created a special triangle, the 30, 60, 90 triangle. So we know from a previous section that this is a special triangle. And a special triangle, 30, 60, 90, has specific ratios for their lengths. And their specific ratios for the lengths are t times the square root of 3 and 2t. Okay, and so what we can do now that we know the type of triangle we're working with and we know our ratios is we can choose a specific point for our point on the terminal side. Okay, so this would be the t and the y would be t square root 3. So we just need to choose a t. To make it simpler for us, the t that we're going to choose is just going to be 1. So we'll let t equal 1. And since we're going to let t equal 1, we now then have a triangle with a short side of 1, hypotenuse of 2, and our last leg of square root 3. And so we can now use this information to help us answer our problem. And we're asked to find the sine of 60 degrees and the cosine of 60 degrees. Well, we know sine, according to our chart here, is y over r, and cosine is x over r. So, from our triangle here in blue, we know that our x is going to be 1, our y is going to be the square root of 3, and our r is going to be 2. Okay. So the sine of 60 degrees is the square root of 3 over 2. And the cosine of 60 degrees is 1 over 2, or 1/2. And that is our solution. All right, now we're asked to find the 6 trigonometric functions of 180 degrees. So we know 180 degrees is a straight angle. Okay. So theta here is 180. All right, it's a complete straight line. And again, just like in the previous problem, we're going to need a point on the terminal side of our 180 degree angle that's drawn in standard position, which it is. So we'll have a point here. We can choose any point on the terminal side. So again, to make it easier, I'm going to choose the point -1, 0. Okay. Since I chose the point -1, 0, I know my x is -1, I know my y is 0, and now I need to find r. And r is the distance from the origin to my point. And so the distance from 0, 0 to the point -1, 0 is just going to be 1. Remember, distance is always positive. So now I can find all of my 6 trigonometric functions. Okay, so I have the sine of theta, which is y over r, which would be 0 over 1, which is 0. I have the cosine of theta. Oh, we know our theta, so I can actually write in the degrees. Let me give myself some more space. So we know the sine of 180 degrees is 0. The cosine of 180 degrees is x over r, which equals -1 over 1, which is -1. The tangent of 180 degrees is y over x, which is 0 over -1, which is 0. The cotangent of 180 degrees is x over y, which is -1 over 0. Any value divided by 0 is undefined. All right, the next one is secant of 180 degrees is r over x, which is 1 over -1, which equals -1. And the cotangent of 180 degrees is r over y, which is 1 over 0, which is also undefined. Okay, and so now we have the 6 trigonometric functions of 180 degrees. Okay. Our next objective, so objective B, that we're going to walk through is find the algebraic sign of a given trigonometric function. So the sign, whether positive or negative, of the 6 trigonometric functions depends on the quadrant where the angle theta ends. So that's the terminal side. Trigonometric functions are based on the values of x, y, and r, and where our point, x, y, is a point on the terminal side of theta, and r is always positive. To determine the signs of the trigonometric functions, we look at whether x and y are positive or negative in each quadrant. Table 2 summarizes the signs of all the trigonometric functions in each of the 4 quadrants. Okay, and so we have a quadrant here, and I'm just going to draw my arrows. We're going to use this to help us. Our coordinate plane here has 4 quadrants. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. Notice in quadrant 1 in this table, our sine, cosine, tangent, cosecant, secant, and cotangent are all positive. So they're all positive. And that's because x and y are both positive in this quadrant. The x values are positive, the y values are positive. Remember, this is the y-axis, this is the x-axis. In the second quadrant, only the sine and the cosecant are positive, and that is because they are both defined by y, or they're both, I guess you could say, defined in terms of y. Therefore, they are going to have a positive sign. Okay, so the y term is positive. In quadrant 3, tangent and cotangent are positive. All right, they are defined in terms of x and y. So if x and y both have the same signs, your expression is going to be positive, because positive divided by positive is positive, negative divided by negative is also positive. In this case, our x and y are both negative, and so a negative divided by a negative is a positive. And then in quadrant 4, the cosine and secant are positive, and that's because they are defined in terms of x. And the x coordinates in the 4th quadrant are all positive. So the acronym we can use to help us remember what is positive is all students take calculus. Okay, all students take calculus. So all, meaning all of the 6 trigonometric functions. Students, that would be sine and cosecant. Take tangent and cotangent, calculus, cosine, and secant. Okay. So in this exercise, we're told that if the tan of theta equals 4/3 and theta terminates in quadrant 3, find the sine of theta and the cosine of theta. Okay, so we know that the tan of theta equals 4/3. that means the ratio, because tan of theta is the ratio of y over x, and this ratio is 4 over 3. So we can let y equal 4 and x equal 3. Okay. Now to find sine and cosine, we're also going to need r, the distance from the origin to our point on the terminal side. So to find r, we'll use the formula r squared equals x squared plus y squared, where r equals the square root of x squared plus y squared. We know x is 3, and we know y is 4. So that's the square root of 9 plus 16, which is the square root of 25, which equals plus or minus 5. Okay? Now, we know r is distance, and distance is always positive. Therefore, we're going to use the positive 5 and not the negative 5. Okay? So if we were to draw a visual of this, okay, we know that r is 5. We know that it terminates in quadrant 3. So this is quadrant 3. That's the terminal side. So we have the point. And we know r here is 5. This is our reference angle. And so our reference angle is formed by the x-axis and our terminal side. Our point is going to be xy. We know the values of xy from our ratio, but we now need to determine what are the sine of those values. So in quadrant 3, our x is negative and our y is negative. So then this would be the point -3, -4. So x is -3 and y is -4. Okay, so in the beginning it told us that tan of theta equals 4 over 3. That doesn't necessarily mean that y is going to equal 4 and x is going to equal 3. Remember, 4 over 3 is the ratio, and there are many different fractions that simplify and are equal to 4 over 3. Okay, so we have to take into consideration everything that this problem is presenting to us to find the values appropriate for the problem to get us the sine of theta and the cosine of theta. So now that we have them, where r is 5, x is -3, and y is -4, we can find the sine of theta, which is y over r, which is -4 over 5. And we can find the cosine of theta, which is x over r, which is -3 over 5. Okay, and these are then the answers to our problem. All right, next exercise. So suppose a Ferris wheel to the right has a radius of 50 feet, with the bottom of the wheel 10 feet above the ground. If the wheel completes 1 revolution in 2 minutes, find the distance a rider is above the ground when the rider is at point A on the wheel. Express your answer in terms of theta. Okay, so what from this problem is very important? Well, we know we're on a Ferris wheel, and if you've never been on a Ferris wheel is a ride that goes in a circular motion. and it has a radius of 50 feet. So here on the image, we can see 50 feet already labeled for us, and we know that that is the radius r. Now the bottom of the wheel is 10 feet from the ground. So this height right here, let's see, this height right here is 10 feet. Okay. If the wheel completes 1 revolution in 2 minutes, so I mean if it goes all the way around, it takes 2 minutes. We want to find the distance a rider is above the ground when the rider is at point A. So this is point A right here. And we want to know when the rider gets to that point, how high up from the ground are they? Okay, so let me just rearrange this here. So we want to know this distance. This is what we're trying to look for. How high is point A from the ground? Okay, and we need to express it in terms of theta. So that means they're not giving us an angle measurement, so we're just going to leave the angle measurement as theta. Okay, so now that we have all our information and we understand the problem, we now need to figure out how we're going to find the height of point A from the ground. So I know that this height, this long height that I drew here in purple, is going to be the total of many small heights. So let's see if we can figure out what are the small heights we need to find. Okay, so the first one here that I see is h. This is h. Right, this height right here is h. The next height that I know right here at the bottom is the 10 feet. Okay, that's the distance from the bottom of the wheel to the ground. And then this middle section right here, excuse me, is going to be the distance from the origin to the end of the circle. And what's the distance from the origin to the end of the circle? That would be r. And we know what r is already. That's 50 feet. So now I know that the total distance from point A to the ground is going to be the total of h. So let me write this out, the total distance. It's going to be h plus 50 plus 10. So before I can get all of my values, I need to figure out what h is. Okay, h. H is one of the legs of this triangle inside of my circle. H also represents the y distance or y coordinate of my point A. So if I were to draw the triangle out here just for us to reference, I have theta, I know this is 50, and I need to find h. Okay, so what ratio from the 6 different trig functions can I use to help me find h? Okay, so remember h is the same thing as y, and 50 is r. Okay, so what trig function will allow me to use r and y? Well, if you looked at our list of functions, you would see that sine of theta, as well as cosecant, will allow us to find h, but we'll stick with sine for this problem, will allow us to find h. So sine of theta is y over r. And I know sine of theta, according to this problem, is going to be h over 50. And I'm trying to find h. So to get h by itself, I have to multiply both sides by 50. So h equals 50 sine of theta. So I have written h in terms of theta. So now that I have h, I can enter it into my total distance equation that I created. Oops. Sorry, erase that. Oh no, what's happening? Sorry about that. All right, so we have 50 sine theta plus 50 plus 10. So to simplify that, I will get 50 sine theta plus 60. And this would be the expression that represents the distance or the height of a rider at point A from the ground. Okay, awesome.